Okay, listen it here. We are going to discuss the atoms chapter. In this atom chapter, we are going to discuss the construction of the atom. We know that every substance is made up of molecules and every molecule is made up of atoms. And atom construction is studied by the many scientists. Firstly, the atom model is given by the J.J. Thomson. According to the J.J. Thomson atomic model, he compared the atom with the watermelon. And then what he said, according to this model, the positive charge of atom uniformly distributed throughout the atom. That means the positive charge is entirely distributed. The positive, we know at present, we know, right? That is, positive charge is totally concentrated at the center of the atom. But according to J.J. Thomson, the positive charge of an atom uniformly distributed throughout the atom, and the negative charged particles embedded like seeds in the watermelon. This model is also called as plum pudding model. Okay, he compared this one just like this. This is a watermelon. Okay, this is a watermelon, and the positive charge of atom is compared with the atom with the watermelon, and the atom structure is compared with the watermelon. The positive charge is uniformly distributed in the entire atom, and the negative charged particles are embedded like seeds in the watermelon. You see, in the watermelon, right? You see the red color material, right? It is a eatable material, and that red color material, like a positive charge, and the black color seeds will be there in the watermelon, and that will be compared with the negative electron. This is according to J.J. Thomson atomic model. What are the drawbacks of this model? The drawbacks of this model is it does not explain the spectral lines. Why spectral lines are produced? That is not explained by him. Okay, it does not explain the spectral lines, and it does not it does not explain the scattering of alpha particles by the metal foils. The next model is based on the Rutherford alpha scattering experiment. Okay, after that, next scientist came as a Rutherford, and his students Geiger and Marston did some experiment. This is the experimental setup that is shown in the diagram. In this, you see the arrow mark, you follow the arrow mark, and this is the source of the radioactive source, and it emits the alpha particles like this, and these alpha particles are made narrow beam, okay, narrow beam by the lead plates, okay, and this narrow beam is allowed to incident on the gold foil. This is the gold foil, it is written it here, okay, and then whenever these alpha particles are incidenting on the gold foil, then their direction of motion is changed, and that change in the direction of motion or the deviation of alpha particles from their original path is called as a scattering. You see this diagram. This straight line is this red color straight line is the initial direction of alpha particles. This black line is the scattered alpha particle. There is some angle theta. The theta is called as the angle of scattering. And the alpha particle is allowed to incident on the zinc sulfide screen. It is allowed to incident on the zinc sulfide screen. This is the zinc sulfide screen, and on this one detector is there. This is the detector, right? This is the detector, and now this detector will detects how many alpha particles are scattering it here, how many alpha particles are incidenting, and how many alpha particles are scattering at that certain angle. Okay, that can be given by this detector. Okay, this is the experimental setup that is used to study the alpha particle scattering. What is the setup? Once again I will revise. And this is the source of alpha particle radioactive material. It emits the alpha particles. They made narrow beam by passing through them, by passing that alpha particles through the through the gap between the lead plates. When the alpha particles passes through the gap between the lead plates, it is made a narrow beam. That narrow beam is allowed to incident on the gold foil, and after that, these alpha particles are deviating from their original path. Then, how many alpha particles are receiving at this angle, certain angle, we can find by using this detector. This detector is movable on the circular scale, and we can place the detector at any place, and we can count how many alpha particles are reaching at certain angle. Okay, and now let us see what are the conclusions from this. What are the observations? The first observation is that most of the alpha particles are passes through the gold foil without any scattering, right? What they observed that most of the alpha particles, most of the alpha particles are passing straight through the gold foil without any deviation. And next they observed that only 0.14% of incident alpha particles are scattered more than 1 degree. More than 1 degree, how many alpha particles are scattered? 0.14%. Very less. Even out of 100, one alpha, only zero point 0.1 alpha particle scattered. Okay. That means nearly if one out of 1000 alpha particles, one alpha particle scattered with an angle more than 1 degree. And the next one is about one alpha particle in every 8000 alpha particles deflect by more than 90 degree. Out of 8000 alpha particles, if 8000 alpha particles incident on the gold foil, then in that only one alpha particle is scattered by an angle more than 90 degree. Okay, right. And the next one, the scattering of alpha particles occurs due to the Columbus force of repulsion between the alpha particle and nucleus of gold foil. This is the observation. The Coulomb, why the alpha particle scattered? For example, this is an alpha particle. Alpha particle is allowed to pass in the straight. Okay, and this is the gold nucleus. This is the gold nucleus. Its charge we can take as the plus Ze, and now this is the nucleus, and this is alpha particle. We know alpha particle charge is plus 2e, and alpha particle is thrown towards the nucleus. There exists some repulsion force between them. Alpha particle means what? Doubly ionized helium atom. Doubly ionized helium atom is called as alpha particle. That means from the helium atom, two electrons are removed, then it is said to be alpha particle. That means two electrons removed means its charge become plus 2e. That means alpha particle has positive charge, and its mass we can take as the 4 units, that is equal to mass number. Okay, right. And there exists some force between them, that is the force 1 by Coulomb force. We know 1 by 4 pi epsilon naught into q1 q2 by r square. Q1 is plus 2e, and q2 is the, we can take as the nucleus charge. Nucleus charge is Ze by r square. This is the due to the Coulombic repulsion force between the alpha particle and nucleus. What happens? Scattering is occurred. What is the meaning of scattering? Scattering means, for example, one alpha particle is going in the straight like this. You see, this is an alpha particle, it is going in the straight like this, and this is the original direction. But due to some reason, if it is deviated like this, and then this is the scattered alpha particle, and the angle through which it is deviate from its original path is called as the angle of scattering. Let us see the next one. And from the Rutherford atomic model, they estimated the size of the nucleus. You see here, the size of the nucleus is about 10 to the power of minus 15 meters to 10 to the power of minus 14 meters. Size of the nucleus is 10 to the power of minus 15 to 10 to the power of minus 14. And from kinetic theory, the size of atom is 10 to the power of minus 10 meters. Therefore, the size of atom is 10,000 to 1 lakh times of size of nucleus. You see here, size of atom is 10,000 to 1 lakh times of size of, you see here, size of nucleus is what? Size of nucleus is 10 to the power of minus 15 meters, you take. Okay, size of atom is what? Size of atom is 10 to the power of minus 10 meters. You multiply the nucleus size with 10 to the power of 5, then you will get the size of atom. That means size of atom is 10 to the power of 5 times of size of nucleus, right? Size of atom is 10 to the power of 5 times of size of nucleus. Is it right? And now that means 10 to the power of 5 means 1 lakh times. If you take the size of nucleus as 10 to the power of minus 40 meters, size of nucleus is, you take as 10 to the power of minus 40 meters, and size of atom is Size of atom you take as 10 to the power of minus 10 meters, then what you will get here? You multiply with 10 to the power of 4 at here, you will get the size of atom. That means size of atom we will get as size of atom we will get as okay, 10 to the power of 4 times of size of nucleus. 10 to the power of 4 means 10,000 times, right? Okay. Now let us go for the next slide. Rutherford nuclear model. Based on the Rutherford alpha scattering, our Geiger Marsden experiment, and they concluded, and Rutherford gave model. Is according to his model, the entire positive charge and most of the mass of the atom is concentrated at the tiny central part of atom. Most of the mass, okay, this is an atom, and this is an atom. What he said the most of the, this is the nucleus, this is the nucleus. Okay, what he said, the entire positive charge and most of the atom, mass of the atom, sorry, mass of the atom, entire positive charge and mass of the atom, entire mass of the atom concentrated at the tiny central part of atom, the whole mass of atom and whole positive charge concentrated at the center. And the next, electron revolves around the nucleus in circular orbits as planets revolve around the sun. How planets revolve around the sun, like that electrons revolves. This point we know already. Next, drawbacks of Rutherford alpha model. That is, according to Rutherford model, according to the classical theory, we know that moving electrons should lose the energy continuously and come closer to the nucleus and fall into the nucleus. Then when it fall in the nucleus, then atom should collapse, but the practically it is not collapse. It is stable. Why it is stable, he not explained. Then in this what happening? What we are telling it here. Then in the classical theory, what happens? Then whenever the electron moves in the certain orbit, at that moment what happens? It loses its energy. It loses energy, loses energy, loses energy, and finally, whenever it loses energy, its radius should be decreased, and finally it will fall into the nucleus. But practically, it is not happened. Next one is, if the electron loses energy continuously, the atomic spectra should be consist continuous bands. Okay, here, if according to classical theory, whenever the electron moves, at that moment, what happens? Then it loses energy, right? Due to the loss of energy, continuous loss of energy, continuous bands should be formed. But practically, discrete spectral lines are formed. Why discrete spectral line formed? That is not explained.